Dear students, following question is a one mark question from test series 12, the very last test series for this season of 2013-14, and it is from bending stresses from mechanics of material. Now you have seen that in all the 12 tests, this has been my favorite topic from mechanics of material because many questions are asked from this particular topic. Here it is given that there is a short axial column which is having cross sectional area as 200 centimeter square. Here elevation is shown of column and section is shown through AA, which looks like this. Further, it is given that the section modulus is 2 into 10 to the power 6 mm cube and it carries an axial load of 400 kilonewton and load of 100 kilonewton on a bracket, and this line load of bracket is 250 mm away from axis of the column. So here we are having two axial loads that are acting perpendicular to face of the column or parallel to the axis, which is shown by this red line. Both these loads will be producing axial loads. If we talk about axial stresses, both of these loads will be producing axial stresses, but here this end will be subjected to compression and this will be subjected to tension due to bending. So this face, let us say this is A, B, C, D. AB will be having total compressive stresses, that is compressive because of axial plus bending. Whereas if we talk about side DC, it will be having compressive axial stresses minus bending, because bending stresses at face DCs, which is far away from action of loading of 100 kilonewton, it will be tensile. So we have to find out that what is the maximum value and minimum value. Face AB, to which this compressive load is nearer, will be having maximum compressive force, and CD will be having minimum force that might be compressive or tensile depending upon the bending stresses induced. If the magnitude of bending stresses increases compressive axial stresses, then face DC will be having tensile, which is least desired in case of design of columns, as you all know. So here axial stresses is simply load divided by area, converting area to mm square, and loading to Newton, we get axial stresses as total load divided by cross sectional area. It comes out as 25 Newton per mm square. If we talk about bending stresses, we know that F by y is equal to m by I. So F, that is stresses, is my by I, where y by I is z, that is section modulus. So F can be written as m by z. So bending stresses are m by z, which is coming out to be 12.5 Newton per mm square. On this side they will be compressive, on other side they will be tensile in nature. So maximum stresses will be axial stresses plus bending stresses, as we talked for face AB, and minimum stresses will be axial stresses minus bending stresses, as we talked for face CD. So it comes out as 37.5 Newton per mm square as maximum stresses and 12.5 Newton per mm square as compressive stresses. Both being compressive, the magnitudes are given by option B, hence B is the correct choice for question 4. Thank you.